So I want to look at a few applications here. We've been working on the rules themselves, the laws themselves, but I want to look at application today. And one of the first applications that we mentioned in our last lesson, but we didn't really do, was finding the area of a quadrilateral by cutting it into triangles. Okay? Now, remember our area formulas that we have for triangles. The SAS area formula, we have 1/2 A times B times the sine of the angle between the two sides. And then we have Heron's formula, where the area equals the square root of S times S minus A times S minus B times S minus C. Okay? So those are the two area formulas that we have so far. Okay? And really those are the only area formulas we're going to use. But we have this quadrilateral, and we know 3 sides and 2 of the angles. It's not any kind of a regular shape that we are familiar with, that we can or have a formula for. So our best way to do this is we're going to have to divide it into triangles. And as you can see here, I divided it from A across to C. I could have also divided it from B across to D. Alright, and in this case it wouldn't have mattered. Some cases it actually does matter. For example, if we only knew one of the angles, then we would need to keep that one angle intact. We wouldn't want to cut it in pieces. Alright? So, you'll notice here, I divided this from A across to C, and you'll notice as a result, this 60-degree angle got split up. Now, I don't know how much of the angle is over here, and I don't know how much is over here. I labeled them angle 1 and angle 2. Those aren't values, they're just ways of naming the angle. Okay? But I can't really use the 60 degrees in any of my trig because I don't know how much is on each side. Okay? Now, my goal here is to find the area of this whole shape. And you'll notice that since I divided it into 2 triangles, I labeled one of them triangle 1 and one triangle 2. That's just to help keep them straight. I can actually find one of those right now, without having to use any trig or anything else, or find any other pieces of this. I can find the area. Which part can I find?
1.
Okay, because what do I know on number 1?
Side angle side.
I know side angle side. Yeah. Okay. So we've got our formula: 1/2 times the side times the side times the sine of the angle between them. So sine of 100.
80 times sine of 100.
Good. 80 times sine of 100, which should be 78.78 if I remember right. Okay, 78.7846. Alright, so we'll round that just to 78.78. Remember, we're rounding all of our sides to 2 decimals. We round our angles to 1 decimal. We'll round our areas to 2 decimals as well. Okay? Alright, so now we need the other half. And I say half loosely because it's not exactly half. We don't know how much it is, but the other part. But right now, I only know this side, and I know angle 2 is something less than 60. And that's not enough to be able to figure out area. Okay? So I'm going to need to use the rest of what I know to figure out things about this triangle. Okay? So what would I do first?
You gotta find the length of the transversal, or however you want to call it.
Okay, we want to find the length of this AC here. And how would we go about doing that?
Law of cosines.
Calculate AC by using the formula for ABC.
Law of cosines.
That's right. Yeah, the law of cosines. I'm not sure if that's what you were saying, but yeah, use that.
You mentioned ABC.
Okay. Yeah, the law of cosines, AC is the side we're trying to find, so it's AC squared equals, and then the angle across from that is what? 100 degrees. So we're going to have the cosine of 100. When you're setting up this formula, these equations, okay, start with those two pieces, because that's the key, all right? Then you just use your other two sides to fill in the rest. 10 squared plus 16 squared minus 2 times 10 times 16 cosine of 100.
18.12. Oh, 18.1 in this case.
Are you in degrees or radians?
How many degrees?
You're in degrees?
Yeah. Said it was 18 point. Well, if it's the side, it's 2 decimal places, right? So it's 18.12.
Yeah, that's not quite
Not
right. Let's try that again. Okay? So you got 20 point. What do you get before you square root it? 411 point something? Okay. And then something else. Okay. So you leave it in a calculator and you hit square root and you get 20 point. What was it? It's 20.27. What's the next number?
8.
8. So you should round it to 20.28. Okay. So that side AC is 20.28. Okay. I'm going to write that in my diagram so that I can see how it relates to everything else in my diagram. Okay. Make sure you do that. Get into that habit, all right? So you can see the different relationships between sides and angles and whatnot. Okay. All right, so now we look at the triangle we're trying to find the area of, and we have two of the sides, but that's still not enough information, okay? We either need the third side or we need the angle between the two sides that we're going to find, okay? Which do you think would be easier to find here? The angle. Now, this second angle is going to be the easier one to find, okay? In fact, we can't find side CD unless we already know angle 2. There's no way to do that, all right? So how would we find angle 2?
We can find angle 1 first and 60 minus 1.
Good, yeah. Find angle 1 first and then subtract it from 60. That's where the 60 will come into play here, okay? So how do we find angle 1? Good, the law of sines, all right? The law of sines. So let's go ahead and do that. We need angle 1, so it's the sine of angle 1 over what?
16.
16 equals,
Sine 100 degrees.
good, sine of 100 degrees over,
And 20.29.
good, 20.28 there, okay? So we've set that up. Notice now we're able to use the law of sines because we have that pair that are across from each other, okay? So sine of angle 1 is going to be 16 times the sine of 100 divided by 20.28.
1.262.
Alright, we shouldn't get over 1.
So what the angle measure is 50.96.
Okay. Angle 1 should be 50.9 degrees. Okay, if you don't round it all along the way, you should get 50.9 degrees. Okay? This was 0.77696 and so on. Okay? You take the inverse sine there and you get 50.9 degrees. Okay.
50.98, so I'm gonna round to 51.
If you don't round it all along here, it should come out.
Ah, okay.
Okay, so yeah, if it was 50.98, then yeah, 1 decimal place would be 51.0. Okay.
51.
Alright. Okay, so if that is 50 degrees, that means that angle 2 is 10 degrees. Okay? 60 minus the 50 is 10 degrees.
Wait, but isn't it 51? 51.
Yeah.
51. Yeah, sorry.
So it's 9 degrees.
Hang on. Copied that wrong. 51. So it's 9 degrees. Thanks. Okay? So we got 9 degrees. So now, what's our goal? Find area. Can we find the area now?
Yeah.
Yes, we have side angle side. So the area 2 down here, we use our SAS area formula again. We got 1/2 times 12 times 20.28 times the sine of 9 degrees. And that equals, I think it was like in the teens somewhere.
Should we use this for a project, or do you want us to just determine?
Okay, so we get 19.03. So finally, we can give our final answer. The area of this whole quadrilateral is the 78.78 plus the 19.03. Okay? So 97.81, and we'll just say it's units squared since we don't have a unit of measure like feet or meters or anything like that. Okay? So right here is our answer, 97.81 square units. Okay? Any other questions here? Comments? Jacob, did I answer your question?
Yeah, but also like geometry wise, like is angle D 100 and or like
Oh,
what?
are these automatically the same?
Yeah, like what angles are like
In this case, we can't say for sure that any angles are congruent. We don't have any parallel lines. Okay? There is something where if the quadrilateral were inscribed in a circle, then these opposite angles would be supplementary. So like if this were inside of a circle, then this angle D would be 80 and that would be 100, but we're not in a circle here. And really we wouldn't necessarily run into that.
Wait, well, why did he put? Oh, I thought it was double multiplication.
Okay. All right, so let's look at another application here. Okay? And this is a good one because how many of you are actually familiar with the game of golf?
Kind
Okay? Kind of. All right?
of. I played it a couple times.
Yeah. All right. So here's the nice thing, okay, guys? you don't necessarily have to understand all the different golf terms that are in this problem in order to solve it, okay?
Well, that's not fair.
Now,
I wonder.
if you run into a problem like this, say on a quiz or a test or something, and it's not the math that you don't understand, it's the situation I gave you, then ask me, okay? And I can explain that to you. I try to avoid things like this on a test or whatnot so that everyone will understand the situation, but it's not always perfect. So, but here, let's explain this one. It says a golfer played his tee shot at a distance of 220 meters to a point A. All right? Well, tee shot starts with the letter T, so even if we didn't know golf, we could probably guess that it's starting from here. And it says we ended up at A and went 220 meters. Okay? Now, the tee shot in golf, that's the first time you hit the ball. So we hit it 220 meters. Okay? You might know enough about golf to know that you're trying to hit that little white ball into the hole over here. Okay? Even if you played miniature golf, you know that. Or putt-putt. Okay? You're trying to put it in the hole. Now the hole is 340 meters away, okay? After our first shot, the golfer had to hit it 165 meters over there to hit it onto the green, okay? Now, it mentions a 6-iron here. If you have no idea what a 6-iron is, that's okay. It's just one of the clubs that you use to hit the ball, okay? Now, here's the part where you kind of need to understand the situation a bit to understand what they're trying to ask. Determine the angle the golfer was offline with his tee shot. Okay? Now we're looking for an angle. What angle are they talking about here?
T.
They're talking about angle T. We tried to shoot it from here to here. We actually shot it from here over to here. So the angle we were off is going to be this angle right here. Okay? Now, once you understand that, this actually is a really easy problem. Because it's just the law of cosines.
That gives you all the sides.
We have all three sides. We're going to solve for an angle. So we set it up cosine of t. And then what has to go on the other side by itself? If we have,
165.
yeah, the 165 is the opposite side, so it's 165 squared. And then we have 220 squared plus 340 squared minus 2 times 220 times 340. And you solve that out, you know. Go ahead and do the algebra. And let's see what t would equal. We ought to get cosine of t to be 0.91427. Remember, you can't subtract the minus 2 times 220 times 340. You got to subtract the other stuff, and then we're going to divide both sides by that product part because it's got the cosine attached to it. Okay? Is anyone not getting that? What? Okay, we know cosine of t, so now to get angle t, we're going to use the inverse cosine. And that gives us 23.9 degrees.
And so you divide both sides by 149,600 cosine t by both sides?
Wait, you got whatever you got for the 2 times 220 times 340. You
Divide.
subtracted the 220 squared, you subtracted the 340 squared.
Subtracted.
You got them to the other side of the equation, right?
Wait, doesn't the cosine t come with it?
No, you got, here. You gotta do the 165 squared, you gotta subtract the whatever 220 squared is from it. You gotta subtract the 340 squared. Okay, and that's gonna equal a negative 2 times 220 times 340 cosine of t. Okay? It's negative because it's minus 2ab cosine of c in the formula. Okay? So now we're going to divide both sides by this whole thing to get cosine by itself.
Got it.
Alright? Then that takes us to here. And we do the inverse cosine. Okay? Okay. Are there any questions? Okay. Let's look at one more example here. Again, I'm trying to give you a variety of examples that you can explore so that you can see the different types of things that we can solve. Okay? Now, here we have a case where we have some bearings. Alright, we're dealing with some hikers. They're navigating. They're trying to find their way around. And we have Ritva and Esko, and they both leave point P at the same time. Now it says Ritva walks 4 kilometers along a bearing of 40 degrees. Now, remember, bearings can be given in two different ways. We could have said north 40 degrees east, or we can simply give the bearing as an angle away from due north, clockwise from due north. Okay, that's how these ones are given. They drew the picture, so you should have been able to see that pretty good. Okay, then it says after that first 4 kilometers, Ritva turns and goes a further 6 kilometers on a bearing of 155 degrees. Okay, and ends up at the campsite here. Esko, on the other hand, walks in a straight line right to the campsite. So there's the situation. We have Ritva and Esko's going in a straight line. Okay? Now, there's some stuff we need to figure out before we even can start to figure out the answers to our questions. Okay? And that is, if you notice our triangle that we ended up with, we don't know any of the angles. Okay. What can we figure out?
And the P and no, you can just tell one.
Okay, when are we?
This one?
No, yeah, this one. We can find out. Yeah, both of them.
Okay, so what would this one be?
180 minus 40, 140.
Okay, so notice Carrie's pointing out that this angle right here would be 140 degrees. And the reason is because this north-south is always going to be parallel to this north-south line. Okay? And if we look at that first path Ritva went as a transversal of parallel lines, these are same side interior angles. You may not remember the term, but should remember the relationship here. These will always add up to 180. Okay? Now, if for some reason you didn't notice that, did someone else see a different way to figure out things? Jared? Or Jacob?
I sort of like borrowed on her idea, and if you like continue the circle of the 155 down to like halfway, then that should be 25 in half
Yeah.
and like part of it.
Okay, good. Yeah, that would be 25.
And if you continue the 140, then you get another 40 and then 65 for that angle.
Okay, good. Yeah. We get this, and this is a total of 65 degrees. Okay, so there's really two ways we could get there. Once we knew the 140 and 155 are 295. This makes a full circle, so if you subtract from 360, you get 65. Or, what Jacob was saying is that, you know, if we use this as a straight line, 155 plus 25 would be 180. And then, let's say you didn't know the 140. You could figure out that this was 40 because it's an alternate interior angle to that 40 over there. Okay? So there's more than one way to figure out your angles here, but both of them require you to pay attention to those parallel lines. Alright?
I could go ahead and point out that Ricky's pace makes absolutely no sense. So she's hiking through, presumably, mountains or forests, right, at 10 kilometers an hour, which means pretty much 10-minute miles. Which means that she's running, assuming that she runs at a normal pace, through the forest, the mountains, or woods with various inclines and declines without
Maybe
losing energy. And by the way, if she ran a 10-minute mile, it would be slightly more than an hour.
Well, actually, 10 kilometers an hour is only about 6 miles an hour.
Yeah, that's what I'm saying.
So-
10-minute mile.
A 10-minute mile.
Yeah.
That's pretty slow.
Yeah, but
Well, maybe,
assume
maybe the
that
shorter
she's like.
path is
Well, let's not-
Worse than normal water.
We don't know who these people are,
Also,
okay?
take into
So
account
let's
terrain.
not overthink and go beyond the scope of, okay, reasonableness, alright?
I'm saying.
These could be any people. There are plenty of people in the world that could
all
get
I'm telling
through
you is
whatever this is in that. The presumption here is they've gotta have a good reason for going way out of her way. This could be a nice paved
Yeah,
path.
the rendezvous.
This could be the through the brush way, okay? So there's a reason why they went out of the way, and there's a reason why they were able to go faster along that way. Okay? So, now, before we even get to part C, parts A and B here, we need to figure out how far Esco hiked, which we can now figure out now that we know this 65-degree angle. Okay? What are we going to use to figure out how far Esco had to travel?
No.
Law of cosines, okay? We know side angle side now. So the distance that Esco went, we'll call that PC to go from the P to the campsite. Alright? That PC squared is 4 squared plus 6 squared minus 2 times 4 times 6 times the cosine of 65. Okay? And you plug all that in and you'll get 5.63 kilometers. Okay? 5.63 kilometers. Okay? For sake of time, you guys, I know you can use your calculators at this point, so. And if you're having trouble with that still, then we need to talk. Okay? So we've got 5.63 kilometers. That's how far Esco went. In which direction? Now here, guys, I want you to pay attention to this, alright? When you're asked for a direction, if the other directions in the problem were given as bearings, what do you think you ought to give your answer in terms of? As a bearing, okay? The bearing is, notice here, it's an angle starting at due north, rotating clockwise, okay? So, notice we already know part of it, it's going to be more than 40 degrees, because 40 degrees would take us along Ritva's path, okay? So we need to figure out this other angle in order to add it to 40, and that'll give us our bearing, okay? So if I had, say, like theta, this is going to be 40 plus whatever theta is, okay? Now we can use sine. Good. Yeah, law of sines. So sine of theta over what? 6 equals sine of 65.
Over 5.63.
Good, over that 5.63. Okay? Work it out. Multiply by 6 on both sides. And do our inverse sine. And what do we get theta equal to?
9.8. So that's
74.
75 and 75. 75.0.
Okay?
75.
So that would be, yeah, if we round to 1 decimal, that'd be 75.0.
And if you have,
Okay?
if it's a side, do you leave it at 1 or 2? No, that's an angle.
1 decimal.
That's an angle.
Angle 1 decimal.
And side, 1,
Okay.
1 as well?
Side 2.
So,
Alright, so 40 plus 75, we have 115 degrees. That's the bearing that ESCO took to go straight to the campsite. Okay? Now, here you can kind of see a little bit of the application. Alright? If going one path, you have to go 10 kilometers, but you're able to go 10 kilometers per hour, how long is it going to take you?
okay, what? If let's say it again.
1 hour.
Think about Ritva's path. Ritva's able to go 10 kilometers per hour. How far does he have to go?
1 hour.
10 kilometers. So it takes 1 hour. Okay? So Ritva took 1 hour. ESCO is able to hike at 6 kilometers per hour on that 5.63 kilometer route.
her path is less than.
Okay, so that means it's going to be less than an hour. We could figure out exactly what it is, but it's going to be less than 1 hour because she's going faster in 1 hour than what the distance has to be. Okay,
That's gonna be really quick, right?
so ESCO's going to get there first.
I figured that ESCO would be the point.
And if we figured out exactly what ESCO's time was, okay, the distance divided by the rate will give us time. Okay, did anyone get that?
Distance equals rate times time, so we just
Okay.
transfer the information.
5.63 divided by 6, so 0.983 times 60, so 56.3 minutes. Okay,
To put it in time.
so that'd be
60 minutes.
56.3 minutes, just so that we can kind of have something to compare to. So ESCO's actually going to get there 3.7 minutes faster than Ritva would. Okay? So, kind of interesting application there. Alright?